everyone. In this lecture, we are going to see about the distributions, that is binomial distribution, Poisson, uniform, exponential, and normal distribution. Here we are going to see about the binomial distribution. Let us know about the introduction. The frequency distributions are of two types, namely observed frequency distribution and theoretical frequency distribution. The distributions which are based on actual data or experimentation are called the observed frequency. On the other hand, the distributions based on expectations on the basis of past experience are known as theoretical frequency distribution or probability distribution. It is divided into two types, one is discrete and continuous. Binomial and Poisson comes under the category of discrete distribution, and uniform exponential gamma normal distribution or comes in the case of continuous distributions. Binomial. The name itself denotes bi means two things. We are going to speak about the two variables, that is two parameters. Here, random variable x is said to be followed binomial distribution with parameter n and p if it assumes only non-negative values and its probability mass function is given by. We know that it is a discrete case, so probability mass function is given here. P of capital X is equal to small x. The formula is ncx p power x q power n minus x. Here x varies from the non-negative number 0, 1, 2, 3, etc. And q, we already know that q which is equal to 1 minus p. Any random variable which follow binomial distribution is known as binomial variate. It is represented in the format x is related to b of n comma p is a binomial variate. Here we have n number of trials and trials are independent of each other and the probability of success is denoted as p, and in every trial there are only two outcomes, that is either success or failure, so only named as binomial. Next, we are going to calculate the moment generating functions for the binomial distribution. So the formula is mx of t, which is equal to summation. Discrete case also it is a summation. This is a moment generating formula e power xt into our p of x form. So this is p of x. ncx, no. So ncx is written as n factorial by x factorial into n minus x factorial p power x into q power n minus x. After getting simplification, we get q plus p into e power t whole power n. This is a moment generating function. Next, we have to find the mean and variance. Mean means we have to differentiate the moment generating function with respect to one time. We get the mean, and finally we have to substitute t equal to 0. So the mean of binomial distribution is np. And for variance, the formula is a of x squared minus e of x the whole square. No, e of x squared means the double derivation of the moment generating function, which has been calculated here. After this substitution in this equation, we have to substitute t equal to 0. We get e of x squared equal to np of q plus np. Substitute the known values in the variance formula. Finally, we get the variance of binomial distribution is npq. Therefore, the mean is np and variance is npq. Let us discuss the problems. A and B play a game in which their chance of winning are the ratio 3:2. Find the A chance of winning at least 3 games out of 5 games played. Okay, so here we have 2 games A and B. I mean A and B persons. Both are playing a game. So generally we are taking P with the probability that A wins the game. Success is generally denoted in the variable P. Then they are given that n is equal to p. Also in this question, winning at least 3 games out of 5. So we have made it as p equal to 3 by 5. Then what about q? It is 1 minus p. So 1 minus 3 by 5, which is equal to 2 by 5. Next we are going to find the binomial distribution p of x, that is ncx. So 5cx, p power x, q power n minus x. So the required probability that A wins at least 3 games is given by at least 3 means what is the notation? Greater than or equal to 3. So we have to find it for p of x equal to 3, x equal to 4, and x equal to 5. Stop it at x equal to 5 because we have only 5 games out of 3. That's all. So substitute in the binomial distribution and solve it. Finally, we get the answer 0.6826. In the next problem, the mean of binomial distribution is 20. What it is? Mean means NP is 20 and standard deviation means it is a root of variance. No, the root of NPQ is 4. Find the parameters of the display. What are the parameters of binomial distribution? N, P, Q. These are all parameters. So we have to find N, P and Q values separately. So substitute all the given parts. NP equal to 20, root of NPQ is equal to 4. So here we have to take squaring on both sides. We get NPQ is equal to 16. Substitute the NP value 20 in this equation. We get 20 into Q equal to 16. Q equal to 16 by 20. What's the answer? 4 by 5. That would be is 1 minus Q. So 1 minus 4 by 5 is answer is 1 by 5. So now we have the parameter PQ and what we have to find the N value. Already we know that N is 20. In this expression, we have to substitute our P value. Finally, we get the answer N equal to 100. In our next problem, if the average rain falls on 9 days in every 30 days, find the probability that rain will fall on at least 2 days of the given week. So the probability of raining on a particular day is given by the rain falling 9 days, right? 9 out of 30 days. 9 by 30, that is 3 by 10. Then what about Q? It is 1 minus B, that is 7 by 10. So in the binomial distribution, we have to substitute the known things. It is given that there are 7 days in a week. So N is 7. We have to find the probability of raining for at least 2 days. Means what is the expression? Greater than or equal to 2. It means it is also reframed as 1 minus P of x less than 2. X less than 2 means what are the possibilities? The probability of x equal to 0 and x is equal to 1 is the only possibility. So we have to substitute x is equal to 0 and x is equal to 1 in this binomial expression and solving it. We get the answer as 0.6706. In the next problem, out of 800 families with 4 children each, how many families would be expected to have 2 boys and 2 girls, at least 1 boy, at most 2 girls, and children of both genders? Assume equal probability for boys and girls. Understand the loss line. We have to assume probability is equally split. That means P is equal to 1 by 2 and Q is equal to 1 by 2. Here, totally 800 families. But first we have to speak it for only one family by considering 4 children. So N is equal to 4. And the P is denoted as assuming that both are boy. Either we have to, because P is a probability of success. So here we have assumed that P is a probability of getting a boy. 2 boys and 2 girls means we are totally 4 children for one family. So equally split, so x is equal to 2. Substituted in the binomial expression, we get 3 by 8. For number of families have 2 boys and 2 girls, totally 800 families. So 800 into 3 by 8 is equal to 300. Next, we have to find it for at least 1 by. At least 1 means x greater than or equal to 1. So x is equal to 1, 2, 3, 4, totally 4 cases now. This is also rewritten as 1 minus P of x equal to 0. So substitute x value 0 in the binomial expression, we get answer 10 by 6. This is for one family. For 800, we have to multiply it. So the final answer is 750. Next, at most 2 girls means what's the meaning? Exactly 0 girl, 1 girl, or 2 girls. 0 girl means in that family there was a 4 boys, so x is equal to 4. 1 girl means there is a 3 boys, so x is equal to 3. 2 girls means there is a 2 boys, x is equal to 2. So this can be rewritten as 1 minus P of x equal to 0, x is equal to 1. We have to find the probability for these 3 things. But what we have done, we have to subtract the total probability 1 from this expression and substitute x equal to 0 and x is equal to 1 in the binomial distribution. We get the final answer as 11 by 6. For total families, we have to multiply it by 800. So the final answer is 550. Next, we have to find the probability of children of both the sexes. That means both the boys or girls. So this thing, we have to subtract 1 minus probability of children of the same sex. That is all are boys or all are girls. All are girls or x is equal to 0. All are boys means x is equal to 4. So substitute in the binomial expression, we get the final answer is 7 by 8. For 800 families, the answer is 700. In the next problem, 20% of items produced from a factory are defective. Find the probability that in a sample of 5 chosen at random. So N is equal to 5. Totally 20% are defective means P is equal to 20%. That is 20 by 100. We have to find it. None is defective, 1 is defective, and we have to find the probability distribution of 1 less than x less than 4. So the probability that none is defective is given by P of x is equal to 0. So in the binomial expression, we have to substitute here. So 0.328. Next, in the probability that 1 is defective means we have to find it the probability of x is equal to 1. And substitute to the binomial expression, we get the answer is 0.409. Next, we have to find the probability distribution for x lies between 1 and 4 means what are the values? X is equal to 2 and x is equal to 3. So, we have to substitute in the binomial expressions. We get the final answer is 0.256. Thank you.